So we're talking about hormones, and we earlier talked about signals, and we mainly talked about nervous signals of the nervous system. But hormones are used when we need the signal to be widely distributed and last a long time. So some more ongoing sort of signals that need to last hours and days maybe will be accomplished using hormones instead of electrical signals using the nervous system. So this is using chemicals. So remember, you run on chemicals and on electricity. Okay, very sophisticated. But for the longer term signals you want and widespread, we're going to be using hormones. So these are your basic glands you need to know about. This one here is the hypothalamus. And the hypothalamus, a lot of things, a heart rate, thermoregulation, thermoreg, I'll put here, learning, memory. It's really integral to a lot of different functions. And right back behind the thalamus, you have your pineal gland, Pineal. What do you got, Jackson? Oh, that's good. And so we got the hypothalamus, the pineal, and right hanging down from the hypothalamus, you have your pituitary. Pituitary. Oh, I forgot the pineal. So the pineal is your sleep pattern. So pineal, think sleep, melatonin. We'll get to that later. And then pituitary, you're looking at growth and reproduction. So growth and reproduction with your pineal. And here we have this butterfly-shaped gland. Okay. So now we'll talk about insulin and glucagon, and I just have this thermostat here just to bring that idea out of homeostasis. Just like the thermostat here, like we have in our classroom, I think it's set at 72, or sometimes I'll set it at 74 degrees Fahrenheit. Just keeps it from getting too hot or too cold, keeps you around this set point. So that's basically what your what insulin and glucagon are trying to do in terms of blood sugar. So right here, homeostasis. And if your blood sugar drops, these alpha cells are going to release glucagon, and that tells the liver to break up that stored glycogen into glucose. So that glucose will then get into the blood and rise up to that set point that your body, your hypothalamus, is shooting for. However, if after you eat a big meal, you're going to need to store some of that glucose away. So the beta cells, the pancreas, release insulin into the blood, and this makes the liver take up the glucose and make glycogen because it knows, oh, there's too much, so it'll make glycogen. It'll also tell your body cells to take up more glucose, so it'll get that energy, and then you'll lower the glucose levels to get down to that set point. So down here, you're looking at raising glucose. With glucagon up here, you're looking at lowering glucose. That's the big idea. Raising and lowering. Your body have a mechanism to do both, to keep you in that middle point. And let's talk about thyroxine here. your thyroid gland. So the hotter things are, it'll inhibit, I'll try and draw, there we go, inhibit thyroxine release, which decreases your metabolic rate. Decrease that metabolic rate, and if you decrease the metabolic rate, you're going to lower the amount of heat your body creates, so lower that body temperature. You might feel like this, like you get lazy when it gets hot. Your body's trying to make you lazy, because if you're out doing stuff, you're burning calories, you're getting hot, your body doesn't want you to do that. Now, the opposite, if it gets colder, you're going to stimulate thyroxine release. So stimulate, and that's going to increase the metabolic rate to generate heat. Let me write. All your body cells are increasing their use of glucose, so that will create a little extra heat for your body, which it needs when you get cold, right? So leptin is a hormone we need to know about, and it is produced by our hypothalamus, and it works on adipose cells, a fancy way of saying fat. And this is what, and remember the leptin is made from the fat cells themselves, and that then goes to your brain, says, hey, we have lots of fat, so we need less energy, and that should make you eat less. That's the whole idea. But this has been found to be very problematic to try to use this to modulate human eating habits and say diet. That's a huge multi-hundred-million-dollar, probably billion-dollar industry. Exercise and weight loss altogether. But increase in adipose cells leads to an increase in the leptin your body has. I think that's covered up on my face right here, but I think leptin goes in that blank down there. And here's melatonin made by your pineal gland. You'll see it goes down during the day when you are usually awake, and then at night it goes up. So we see these cycles pretty clearly with melatonin. When you're sleeping, they go up. When you're awake, they go down. So this has been something that's been shown to be pretty effective in helping people sleep better, is to give melatonin supplements and to treat things like jet lag. So here we have the Y and the X chromosome producing the differences we see in our sexes. Here, these are the testes. The testes produce testosterone. And down here, and remember, from that Y, from the Y sperm to make that XY, that's where you develop into the testes. If you have two X's like here, that'll be female. This will develop the ovaries, and that will produce estrogen. And progesterone, I'll put it here. You can write that down below. Just can't see it from here. So these hormones will produce in males sperm production and also secondary sexual characteristics like sex drive, larynx growth, and this will, this creates that deep voice. And here, body hair, beard growth, and here it's pointing to the side, but muscle growth. And here, external genitalia development. Genitalia development. And for females, that estrogen and progesterone will do some slightly different things. breast development. All right, up here. Wider hips. Usually more fat deposit under the skin. Females tend to carry a little bit more body fat. Then we have body hair. And for females, same thing as males, the external genitalia development. Yeah, all being produced from the ovaries there. The hypothalamus, moving on to the menstrual cycle, gonadotropin releasing hormones will release LH and then FSH, luteinizing hormone and follicle stimulating hormone. LH will lead to development of estrogen, FSH, progesterone. And after they're produced, they will go back and inhibit the production of more hormone. Your body, remember, is trying to keep a balance. It doesn't want to keep making LH and FSH if it doesn't have to. So those hormones will do a negative feedback. And this is also, we'll get into more later, but how birth control works. The pill normally is referred to. You'll get a dose of estrogen or progesterone, and that will act on the hypothalamus to prevent the release of the FSH, and the LH will prevent the release of an egg, which is a convenient way not to get pregnant, not to have an egg there. So, causes and treatment of diabetes. This is normal. Healthy pancreas making insulin, and you'll see this is a glucose receptor, and it allows the glucose to come into the cell where it can make energy. And that's good. This is what you want. So type 1 diabetes, pancreas doesn't make insulin, so no insulin made. And since there's no insulin, the receptor can't be stimulated, and the glucose can't get in, and it stays in blood, which really jacks up. Stays in the blood, which increases a lot of blood pressure and creates a lot of damage to a lot of internal organs. And type 2, the body still is making insulin, but the body is not responding to it. I can't see back here, but I'll go back and write that in post-production. But the body does not respond to the insulin, and therefore doesn't take up the sugar into the cells. And risk factors for type 2, unhealthy diet, physical inactivity, and 1 in 3 people type 2 is overweight, and 1 in 10 is obese. So there's a strong correlation with body weight and diabetes. So what you need to do is eat healthy diet and be physically active. Avoid excessive weight gain. Yeah, there's something about that weight gain that really turns off those receptors to being sensitive to insulin. And follow medical advice. Well, these are all easy to say, hard to do. So that's the thing about it. Food is so addictive these days, so tasty. It's really tough to stop eating some certain foods, and physical fitness is something that we need to take a stronger approach with. And I just threw this in here because a lot of, in terms of obesity, being overweight, a lot of times these European countries, we have very high rates of obesity, but you don't see those places having the highest levels of diabetes. You have this Middle East, Egypt, North Africa, Chile, down here, and then you have, this is Papua New Guinea, I think. So these are all areas where people there's no excessive, they're not as overweight as other places. So there's some other genetic things happening probably. Genetic, environmental. It's not just diet that drives the rates of diabetes. So just want to point that out. But I believe this is type 1 diabetes, which is also called juvenile onset.